Hi, I'm Tom Hackett, and today we're going to cover part 2 of the simplest neural network explanation ever. And this utilizes a spreadsheet, and this is a printout from that spreadsheet, and you can work with that spreadsheet yourself if you like. It's linked in the description. So I'm going to pick up where I left off. Last time we showed how we calculated a convolution layer and a normalization layer as part of a neural network that's intended to figure out if the image shown here in green is the letter X or not. That's the operation of this neural network. And so the first thing we did was we ran convolution, then we normalized the data. But now we have to get down to a point where we have effectively these groups of cells, these blocks, voting together on whether this shape is the letter X or not. So how are we going to get to that? Well, what we're going to do is we're going to reduce the amount of data that we see here in these three arrays. And we're going to do that with a pooling layer. So pooling in neural network terminology is a step of reducing the amount of data that you're dealing with. Okay, now there's different ways that neural networks will reduce data. In this one, we're going to reduce it by averaging. So the first thing we're going to do is look at this top left square, and we're going to average these numbers together. So there's 9 numbers altogether, and then we have, all of them are 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. They total to 9. Divide by 9 numbers altogether gives us an average of 1. And that's represented here as the 1, which I have color-coded also in green. So that means that this square believes 100% that what it was looking at was the letter X. And now we're going to do the same thing with this square. So here we had 6 ones. 6 divided by 9 values altogether gives us 0.67. So that's going in this square. And it doesn't believe quite as strongly, so it's color-coded yellow. And then we do the same thing, averaging out the data for the other squares, and we get all the numbers here. And we do that for this filter function, and then for the next one and for the next one, so we get all these numbers. Now, you'll see in some cases these squares are color-coded red. They've got the lowest probability that what they were looking at was an X, and so that's sort of like the worst guessers, you might say, and the dark green are the best guessers. So to make this manageable, we're just going to take these and put them in a vertical column, a vertical array. So we're going to move this one over here, this 0.67 over here, this 0.56 here, and the same thing with the rest of these to get this vertical array of numbers. And if you look at that, you can see, well, these red guys, they didn't do a good job of guessing that this was an X at all. And you and I both know that this is the letter X, right? So what we're going to do is we're going to say, those squares corresponding to these red numbers, they didn't do a good job, so we're going to cancel out their vote. Okay? We're going to give it a weighting of 0. And so this column right here is a weighting value. So if the square did a good job guessing, if it was green or the light green or the yellow, then they get a 1. They get to vote with their full guesstimate. But for the ones that were the orange and the red, we're just going to zero those out because they did not do a good job guessing. Okay? Now, with this weighting process here, weighting process is actually a manual training that I've done for this neural network calculator. And you'll hear about training in real neural networks. There's a big difference in the way they do training. Now, I'll describe that in a minute, but let me just continue on with this voting thing for now. So, for all the ones that we assigned a weight of 1, they get their full vote. So we'll pass that into our last column. And for everybody that was a 0, they just get zeroed out. And now we're just going to add up these numbers, divide them by the total number of blocks that voted, and see what that average is. And that averages out to 0.79. So sort of like a 79% guess that this was indeed the letter X. And so this other aspect about neural networks is things are never black and white. They're always shades of gray. And so in the spreadsheet, you'll see at the very top of the spreadsheet that there's a statement that says, is this the letter X? and then it'll say either yes or no in text. And I just have that set a threshold that if it's greater than 0.7 or greater, then that text will flip to yes. But if it's less than 0.7, the text will flip to no. It is not the letter X. So that's like how this whole thing works. Now, in this case, it was 0.79. That's greater than 0.7. So yes, this is the letter X. That's what the neural network calculator says. Now, how does that differ from the real-world neural networks? Well, it's all about this training. So what I did, I just eyeballed it, right? I looked at it, I said some of these were good guesses, some were bad, and I gave them all or nothing. Either you get your full vote or you get 0 vote. But in the real world neural networks, they'll look at this and they'll calculate an error value. How much was that particular block wrong? And then they'll feed that error back into the calculations to rerun it to get less of an error out. And they iterate that over and over and over again to get the network performing with the least amount of error. And that uses a mathematical process called gradient descent. So you'll hear about that, and there's good videos that explain what gradient descent is. For my viewpoint, I think it's probably the most complicated part of the whole neural network thing. But anyway, let's take a couple of examples. Now, you and I would agree that that's a letter X. Let's take something that's not quite as clear. So let's look at this. I plugged this array into the neural network calculator. And many of the things are missing, right? So is that a letter X or not? This gets into the area. For me, I would say, okay, that could be an X, you know? But different people might disagree on that. And we would have to agree on some kind of gut feeling. Is that an X or not? And the neural network's kind of the same way. This neural network says, yep, that is the letter X. It met the requirement. It's close enough. It has enough of those X-like characteristics to be considered the letter X. But now, I decided to remove just one of the green boxes. I removed this one to end up with this right here. And so you can see that green square was removed. And now that was enough to tip this neural network to the opposite decision. So where that one was an X, yes, it says, no, this is not an X. But you can change the images in the spreadsheet and experiment with that. You can change the weighting factors. You know, you can train it yourself. You can change the threshold value to what crosses the threshold between being an X and being a not an X. I encourage you to do that. I hope it's kind of fun and informative and helps you to get this same kind of intuitive feeling for neural networks. So, but thanks for listening, and I'm Tom Hackett for Whiteboard Wednesday.